Who's, no, no more. Thank you so much for having me here. Who has heard of ChatGPT? Amazing, still few people who have not, so I'm so excited about that. I'm going to tell you about it today. A little bit more than that. So I am the founder and CEO of MeltMinds. MeltMinds is a startup. I started about 3-4 months ago. I used to work for Microsoft before that. And it is an organizational intelligence platform, and we are all about AI. AI for people, AI powered, AI using OpenAI, AI using organizational data, AI using large language models. And if you'd like to know more about us, please follow us on LinkedIn. I've already mentioned about myself, but feel free to follow me on LinkedIn as well. I share a lot of information around AI, responsible AI, large language models, OpenAI, as well as D&I. So when I say D&I, I'm talking about diversity, equity, and inclusion. So our platform is all about diversity, inclusion, equity, and inclusion, and the productivity side of it, and the financial side of it, and the organizational progressiveness side of it. So if you're interested in any of those, please follow me on LinkedIn as well. Okay, this morning we're going to talk about OpenAI, and then we're going to talk about ChatGPT. But before we go any forward, does anyone know why OpenAI became, when it came in, when the new ChatGPT model, which is not the 4 now, 3.5 or 3, came out in November, why did it become big? What happened? Yeah, please.
Uni students started using it.
Very true, very true, very true. So it became accessible. It made it available to just almost anyone and everyone. And it didn't become available to anyone and everyone just because it was a website and you could just log in and you could do things with it. It actually did take AI to the next level. It did take the information that is accessible to the next level. It took the interactability to the next level. So any generations of AI that we had before in terms of machine learning, in terms of deep learning, they were still talking like robots. And then then OpenAI came, which was not talking to us like robots. It was not limiting the information to a particular data set. It was literally taking everything that we do on internet or World Wide Web or our large search platforms of the name I'm not supposed to say here. It took all of that into a very empathic manner into providing you with context. So if you ask something, it will provide you information for that. But if you ask something and provide it a context, you tell it like, I want to learn about AI, but I want to learn AI for making robots, or I want to learn AI for going to, space. It will actually give you things to do with your context. So that's one of the very powerful, and speed and all those kind of understanding human language, all those kind of things really made it quite big as well. But the topic that we're doing today is slightly different to that. We're actually bringing it back now. So one of the problems that happened with OpenAI, or not problems, but it's amazing, but what is still a problem or not widely understood is, okay, this is amazing. It's good for uni students. It's good for people just wanting to know information. But what can we do of it in our business? We have a large organization. We have a lot of data. We don't have very good systems, or a system that tells something to any kind of question, be it HR question, or be it a customer question, or be it a finance question. We don't have this kind of, it would be amazing to get this kind of platform internally, but how do we do it? Do we really have to do all the work that OpenAI did to make something similar to that for our organization? where do we start? So that's kind of where, and if we do use OpenAI for all those kind of questions, then where is my data going? Am I asking the question and telling my information to the worldwide web, and it's just going to grow there? So all those questions led to concerns that the organizations are talking about how to go about, bringing it into the organization. So Azure came up with something called, or Microsoft came up with something called Azure OpenAI Services. What is it? Anyone has an idea?
Hosting your own models.
Sorry?
Hosting your own models in Azure.
Exactly. So not just the models in Azure, but it actually lets you create an instance of it. So OpenAI is a model. It lets you create instance of it as well. But when you create that instance, it's still in the OpenAI platform. It's still outside your organizational environment. It's still outside your organizational governance. But what we have all been doing with Azure is we've been bringing our virtual networks, our privacy into our cloud. We've been bringing our governance into the cloud. We have, as you will listen to some of the talks later today, it is way ahead in terms of security, privacy, securing governance, how you do things in Azure. There's a lot of maturity, if you could say, inside organizations that have already come into Azure. So what we do now with OpenAI is OpenAI services becomes one of the resources inside your Azure cloud. It lets you create models. It lets you train it with additional data. It lets you add your organizational data on it. So that's kind of what we will look at very shortly. So we can do it. Now, the question is how we can do it. So think about inside an organization, you have a user. That user can be an internal employee. That user can be a customer. Now, that user is engaging or asking a question to an app. That app can, again, be an enterprise internal app or an external app. That question goes to your organizational knowledge. It picks up the context. It takes the, whatever the information it needs from the organizational knowledge. Then it takes it to OpenAI service that is actually sitting inside your organizational Azure subscription inside maybe in your country's data center or location where you have all your other organizational resources and governance and enterprise applications and line of business applications. So what you then do is bring all of that together and back into the answer to the user. This is called prompting. This is called grounding. You might have heard different names. This is exactly what, to some extent, Bing is using to do that, to provide you the chatting features, functionality that it has now in the browser search. But the problem with this is when you tell something to a API for a call in terms of providing context, that is, how much information can you send? Azure and OpenAI are going to charge you by the tokens. So when you ask a question, your question gets broken into words, and then they get broken into certain tokens, and you get charged per token. So how many chapters or how many of your organizational information records can you send in every call? Not that many. If you do, you'll be poorer and poorer, and Microsoft will be richer and richer, which they do want, but they don't want it ridiculously at your expense, at the customer's expense. So you have options like this. So what happens here is you have your organizational data that could be sitting in the cheapest data source possible. You can have it in the cold store if you want, or any of your Azure cheapest data stores. It can be structured. It can be unstructured, whichever type of data that you have that you want to use for your organizational context. What you do then is you put it through a search layer. What that search layer does is this embedding service takes your large amount of data and converts that into vectors. Has anyone heard of vectors? Well, there we go. We've got some techies in the room. excuse me. So what vectors are in the layman terms, it's literally dot points floating in the air in a large database, and the separation of those dots in angle from the 3D space determines how alike they are. So this is way further than the older technology in which to find out how two texts or two pieces of information are similar. We used to compare, what are the similar words? Does the meaning come out to be the same or not? So that was really hard, and that was not even always correct. But when you convert every piece of information into a dot in a 3D space, angle between them can very accurately tell you how alike is the information. Now, why do we care how alike is the information? What happens is, think about a scenario for an insurance company. Now, they have a lot of data, more than maybe I think a lot of other businesses. Policies, claims, information about how to create a policy. So their information is large amount of information in documents. Now, when a customer has an incident, they don't want to, they don't really care about what information the company has to go through, or a bot has to go through, or an application has to go through to provide them the information. So all that customer cares is, as if you can read it up there, I left my iPad in the car, my car's stolen, is my iPad covered or not? That's all they care for. They don't have any other, and the less questions they're asked about it, the better it is. So what happens is, this text now goes through the OpenAI embeddings, similar to what we did in our search, but now this is getting broken down into vectors again. So it's again, now this question is getting into dot points. Then quickly we compare those dot points with the dot points that are in our database, in our search layer, instead of going through all the large text that was there. So that's how it gets that answer quickly, but it is still organizational data. So it only knows, say for example, in this scenario, that content up to $1,000 is covered. It does not know if the iPad is covered. We know that quickly, that contents up to $1,000 is covered, but it still does not know that the iPad is covered. So what does it do? At this point, similar to the previous model, we push it back into the ChatGPT-4, as a prompt, along with the information that we quickly picked up, and that information looks up the generally available information from OpenAI or internet, whatever you want to call it, and goes back and says, in an empathetic manner, we care about it, and the only good thing here is your question is, to respond to your question, your iPad is covered, because that's all the person cares. They do not really want to know that I now have to check for my iPad price, how much was it before, how much is it now, is it covered or not, and things like that. The only thing they care about is, in an empathetic manner, I'm in a problem, what is my solution, what is my clue, how can you settle my anxiety? And that's where these kind of solutions and these kind of use cases really help. What I want to do is very quickly jump into our very familiar Azure portal. I'm assuming everyone's seen an Azure portal. Yep, cool. So this is a resource group, and what you've got in here is all the resources that made my application. So you've got things like your standard stuff, and you've got the Redis cache search, and you've got things like here, which we didn't have it over there in the diagram, but you can put things like translator, form services, if you've got forms and things like that. And if you're working in multilingual geographies, you can actually bring that in together as well. So all of that makes this kind of solution. Now, I'm going to jump into just a little interface and show you a couple of things. So this is based on a repo that is publicly available in Git. So if anyone needs, we can share that after as well. So what I did was I uploaded a few documents into an interface here where you can actually browse the files just for testing purposes that you want to use as your organizational knowledge for the solution. And if I show you here, these are some of the ones did last night. It seems like some of them went through properly, some didn't. So the JPEGs were actually the forms, but seems like they didn't go properly. When I say go properly, is they've been converted, but the second column says embeddings added or not. So embeddings is the vector points that we're talking about. So all it's done is done that for 2 PDFs here, and those PDFs are, if I could show you here, they're actually, they are just a couple of policy documents. One's from NRMA and one's from, I think, Allianz. So if now we go and ask a question here for something to do with what you would expect in an NRMA and Allianz policy, it will tell us that the answer it's getting from those documents, or it could not find in those documents, because that's the context we are asking the question in. Any suggestions for the question that we should ask? Come on.
Is my policy valid?
That's a good question. I don't know. Let's find out. Okay, so is my policy, oops, sorry, wasn't supposed to clear, was supposed to enter. Is my policy valid? Okay, oh no, it did go through. The provided text does not contain information to determine the validity of your policy. So maybe because it's the policy more like the information, it doesn't have any policy number. We didn't provide it any of the user context, any of the answers that it could. But you can see that the source it's getting here is from these JPEGs and not from the policy document, because these JPEGs are actually sample forms of people's policies. So that's why it did not go to the policy details, but rather it went to the actual instances of people's policies. So let's try to ask for something that you would look for in a policy itself.
Do you cover unlisted drivers?
Okay. Okay. Are unlisted drivers covered? Okay, this information does not mention anything about unlisted drivers either. Any other suggestions? I tried one last night, that worked, so let's try that. I asked it, what is required to get a insurance policy? I think it worked last time. It might just decide not to. Okay, there you go. It is picking something. And it's interesting because it's picking even these information like name, address, policy number. It's picked them up from the instances of the forms and not from the policy document itself. But that's really the thing as well with when you bring things into, this is not even fine tuning a model. So what happens is to bring it internally, what you can do is you can ask questions, you can add additional data as a supplemented source, or you can actually change the model itself. To change the model, originally everyone thought, it has so much information, we give it a little bit more information, it should just work amazingly, but it doesn't. So fine tuning, that's what fine tuning is called. Fine tuning is not as recommended a solution. You would go about fine tuning if you really if any of the other context is not, solutions is not working for you and you really need to fine tune it. But what, even in the other solutions, what happens is you have to provide it information and then you have to prompt and see what kind of information is being picked in which way. So that's where a lot of information really comes in handy as well. So any other suggestions or questions actually? Can we, are there any questions in this context or anything that we've talked so far?
Just a question on the kind of domain specific nature. So this is about insurance. Are there different OpenAI models for different domains that would match or base accurate?
Not yet. I would see that as being a very good actually source or industry solutions. Hopefully they come, because you're right. What it does is what we are doing is there's a base model and base architecture, and you have your scenarios if you want a rich data source of your organization, or if you want just small context of your organization to ask the questions. But what you just mentioned is there a industry vertical of each of these models available as either an Azure-based solution or as a LLM by itself? I do not think so at the moment. So you can, though, create it very, very easily. I use the word loosely. But what you can do is this same architecture that we were looking at, you can actually use that to, so what we talked about, our context was talking about an organization. So if you are an insurance company, you bring all your data into, if we can go back here. Oh. Sorry, was supposed to go back here. Okay, so in this scenario, what we talked about, this knowledge base being of one insurance company, but it doesn't have to be, right? So if you are an insurance provider, or if you're an aggregator, and you, like I know of in the banking scenario, there are brokers, but then there are integrators that provide their business case. Business is providing a platform to brokers, so they are a little bit better than most banks, but they are a little bit more standardized than individual brokers. So if you're providing that as an integrator service, and your business is all about providing one domain knowledge, expertise of that domain knowledge, there's nothing to say you could potentially, you can't use the same model as that's in that service. Yes, please. Can we please have the mic, if possible?
I can speak louder. This service is only available in 3 regions.
That's right.
Europe, Central Europe, 2 US region, and for the insurance company in Australia, banking, government, there's a simple policy: you should not use.
You are spot on. So I'll just repeat the question. The question is the context that we're using here for insurance, and even for a lot of other contexts like government context as well. We are in Australia so particular about when we are where we are storing our data. And thank you so much for asking that question. And sorry, I didn't get your name.
My name is Yega.
Yega, thank you so much, Yega, for your question, because that is the top of the mind for everyone here. Like people right now, organizations even are struggling still in Australia to go to even make a valid business case internally to go to cloud, let alone to go to, and that's real. We have it. We have the problem in Australia that we like to keep our data here. We like to know that every service that is available when we go to cloud, it's here in Australia, not just the main data center, but any processing service even that is happening on top of that is here. And that is for a number of very good reasons. So you have a very good point. None of these, or not none of these, but the OpenAI services, the nice circle logos here, they are only in 3 regions right now. They are in US, Europe, and what was the third one?
US West, US East, and Central Europe.
That's right. So 2 places in US and one in Europe. But what my Whisper understanding is, or not the Whisper API. So Whisper is another an API that you can use also to engage with OpenAI API services. But what Microsoft is looking to do is, it's actually speaking on behalf of Microsoft, who I do not work for, but my understanding it's actually coming. The whole idea of having it as inside Azure is to have it in your data center. So it is coming. They're picking up regions in as they're growing. But you have to remember, up until, or even for me to get OpenAI within even Azure, within even the data centers that is there at the moment, and I do a lot of work in this space, I had to go through a number of forms and approvals. And there are multiple reasons where you have to be mindful when you're extending to so many other areas, so many other customers, and that is one, these things take a lot of compute. So they have to, think about that and make it a good service. But at the same time, you have to have a responsible AI mindset. So when you want to use these, just the way as powerful it is externally, it is still just as powerful inside Azure as well. Rather, you probably even have more access because you have more power to do things and use it with the information that is not already in there. So so it's coming. And the exactness of coming, I'll let Microsoft, if anyone's in the room from Microsoft who could share that. 5 minutes left as well. So, but thank you so much. That's a very good question, and that's spot on. That right now it's not in Australia. It should be coming, just like any other service that comes. It slowly expands, but when, I do not know the exact time frame.
Actually, do you have any idea about being in preview? Because I believe it's just that these regions as part of being in preview. Do you know? Are there any timelines about when it might be coming out of preview?
I can ask that question and get back to you, but as I said, I do not work for Microsoft, so I do not have the inside knowledge, and it's good that I do not. Yeah, but if you want to connect after, I am talking to a lot of people in the OpenAI space internally, in the AI space, and with help from Microsoft with startups as well. So I should be able to take your question.
That is great, because I'm actually doing something related to this, and I have to go through a lot more difficult hoops than this, just because Australia a bit. So yeah, I'll talk to you.
Yeah, absolutely. Love to. Thank you. Any other questions? We have a couple of more minutes.
Just one.
Yes, please.
So basically, you can request Microsoft for OpenAI.
That's right. Yes.
And probably they will be giving you private preview.
Absolutely.
Probably in 15 to 20 days.
That's right. So that's absolutely right. But even that is not in Australia. That's the thing that we were talking before. So you can even you brought a very good point. So right now, if you go into Azure and you just try to create an OpenAI resource, you can't. Not everyone can. You have to fill in a form. It takes about 10 days or so for you to be accepted, and then you can actually get the resource. And it's still not in Australia at the moment, even after you get that. Okay, we've already done the demo. Just a quick announcement before we go. We are actually starting to do some enterprise OpenAI training. So if this was of interest to you and you would like to know more, talk more about your business context, please scan here, and I would love to hear from you. And thank you so much for today.
Yes. All right. Am I officially in the virtual world? Yep. All right. Hi, everyone. I'm Michael, MJ, known by other people. Currently an independent consultant, aka not employed, or working on startups that's probably not yet known. But also I'm an Azure MVP, and primarily I'm in the .NET Azure world and the emerging tech. So, LLM is one of them. Blockchain was one of them as well. IoT as well. And lately, I've had some interest with neurodiversity because my son is autistic. So this is kind of like my lifelong journey to know more about, how to connect, the world of technology and that kind of space. For today, I'll be sharing more of the lessons learned of lessons learned in the past 6 months of working with GPT, really, and some of clear-cut limitations I've seen already, and what are some possible approach, or on an architecture point of view, or on an architecture lens, how can you possibly address some of the problems, right, with those limitations. So when we started this journey of GPT, right, everyone's so amazed. What we literally just did was, hey, I have an app, talk to OpenAI API, and do something, right? So we have an app. So we came up with an idea wherein put your risk profile in your mobile app, and then encapsulate that as a prompt, and then send that to OpenAI and come up with a recommendation, right? It's gonna recommend some stocks, it's gonna recommend some, investment advice here and there. But in the first 2 weeks that we've kind of done this, we already saw a lot of problems. Number one is that very obvious is that you cannot control what the user will ask, right? In a way that obviously as much as you can, you wanted to really force them into asking just investment or finance related questions, but most often than not, they would still try to do something else. Second is that OpenAI API, whether it's on Azure or in OpenAI, they're relatively expensive, right? So it's not yet economically viable in a way that it's not as cheap as an Azure storage or a Azure function compute kind of capability, right? I mean, we're not talking about $1 per call, but it's cents. But 1,000 of that, of that call would be in a 2-digit dollar already. So that's why you still have to consider that. Then the problem that we had as well is that the advice that it was generating was very generic in nature. Well, the more we thought about it, it kind of makes sense because LLMs or OpenAI LLM in particular, GPT in particular, is capturing the whole of the internet, and it's kind of generic in nature. It's not specific for investment or finance, right? And then the other bit is that there's a token limit when you actually create a prompt, meaning you can't have your whole risk profile and all of your financial transaction histories from 1990 something pass into one prompt, right? You can't do that, right? So that's one limitation as well. So how can you talk to an LLM that knows as much detail as possible about you and recommend a good advice? So that's why it's kind of a dead end for us. As well as the last bit, which is very important, you're actually putting the private information of that someone. As part of risk profiling, you have to understand what's their annual salary, their tax brackets, their the suburb where they live in, those kind of stuff, right? And it's all private information at risk. The moment you actually prompt that to a public LLM, that's one way or the other, it feeds into that system, right? Whether it's through telemetry, logging, or whatnot, right? So we thought, what if let's try something else? You can't just let a mobile app talk to an API and be done with it, right? So what if let's use an API somehow, right, to kind of manage this, right? So you come up with a function that talks to a database and also with Redis caching to kind of save, to address the cost around Open API, right? Instead of if someone asks specific advice about, hey, what's the current price of Bitcoin today, or something like that. So, and if 1,000 people ask the same question, you don't have to ask ChatGPT the same question over and over, right? So that's one way of putting it. The other bit is that what if all of those private information, you try to silo them into a specific database record so that you kind of separate the concept of prompting or the concept of GPT or the chat into retrieving the information. And we've discovered this pattern late December, early January, it turns out that other people or other companies are actually having this problem of what is the pattern, right? Like Tina showed earlier, that's one of the patterns to look at. But there are actually more. And that's what I'll be showing you in the next couple of slides. So there are a lot of emerging architecture, and the way I'm seeing it at the moment, there's no clear winner yet of where it's going. So we're kind of like back in 2015, 2016, wherein, hey, we have Docker, but which orchestration software are you going to use? Are you going to use DCOS, Docker Swarm, or Kubernetes, right? So we're literally at that point right now. We have GPT, we have LLMs, but what architecture, what kind of like pattern are you actually going to adapt, right? So the rest, these are like some of the, at least in my books at the moment, they're like the top 3 architecture pattern to look at. So first pattern is called RAG. Yeah, it's Retrieval Augmented Generation, wherein like it uses cognitive search. So if you're in the Azure world, this is kind of like a way that, hey, you use cognitive search to dissect all of those kind of like non-GPT information. So whether it's on the database, in your SharePoint, in your Dynamics, or anywhere really, right? So you kind of like use cognitive search for that one to kind of like query a knowledge, right? You're not actually creating, or you're not actually retrieving an information from the internet per se. You're retrieving an information from a knowledge base. So that's why you're using cognitive search. But then once you have that knowledge, now you want to create a human-like experience, or like one way of putting it, it's like your formatter, right? You're now using GPT as a formatter, or kind of like the way it's like saying that, hey, this is your raw JSON data, and now you want to convert it into your kind of like almost UI ready kind of like response. Okay, so yeah, like you're basically using just ChatGPT for generating the response, but you're not actually using GPT to actually retrieve information, right? Sometimes you can marry them up, like like for example, if someone still asks, why is the sky blue, right? You can still use GPT to answer that question, but one approach of, to do this is that using this kind of like pattern, you can actually, at an app server orchestrator level, you can kind of like block already those kind of like nonsense or kind of like related questions asked by the user, right? So you don't have to go the whole RAG cycle again, right? The other pattern that's kind of like emerging as well, actually this is like how we actually used it for RAG. So like for example, using prompt engineering, by the way, you can actually use the same kind of like template for if you go to Azure Samples, but we've kind of like changed the data set, obviously. That's more fitted to finance and investment. So that's kind of like what's different here. So we've kind of like pre-configured this GPT with saying, hey, you're a financial advisor with key insights and analysis on stocks and alternative investment market, right? And like that means that kind of like personifies already. So so we keep on saying grounding. We're kind of like grounding the GPT already that, hey, this is who you are. If someone asks about Xbox or someone asks about PlayStation, you're not gonna answer that, right? Because it's not relevant to you. So that kind of like sets the tone already that, hey, this is who you are. Okay. Then this tick here is using the semantic ranker. So in cognitive search, you can actually rank the how relevant the information is. So if you take that, it's going to use that capability as well. So for example, if you have a lot of data within your knowledge base, obviously just like when performing search, right, you need to rank them somehow. So if you tick that, it's going to use that ranking capability. So yeah, like for example, if I ask what sector should I invest, so tech is down and probably a good one to invest. Like healthcare seems to be stable investment. Energy sector have shown positive result this past year, right? Like if you ask this to ChatGPT right now, it's not gonna answer that because number one, ChatGPT has a data set until 2021 only, right? Q4 of 2021. So it's not aware of the 2023 data, right? So you can't really just use GPT or ChatGPT, the public one, for this use case. Second is that obviously, privacy again and those kind of stuff, right? But here, the advantage of RAG is that you can actually retrieve like, quarterly reports or like, PDFs and like Excel, CSVs and stuff like that. Like this kind of works, right? Like for that purpose, it's kind of like saying here is an assistant. So it's becoming an assistant kind of like a use case rather than like, hey, I want to find the truth or like the, the ultimate answer, right? So when I asked that, so it kind of like analyzed that based from that data, and then there's a citation that, hey, this is the quarterly report from the stocks, right? Then when I say, how about cryptocurrencies? So the good thing about ChatGPT is that there's kind of like a concept of, like relevance, right? Like because in the first question, I did ask like, what should I invest? And when I asked on the second one that how about cryptocurrencies, it's already implied that I'm also looking for investment advice, right? So that's one kind of like advantage of why you still want to use GPT instead of just going full on with a search capability, right? So crypto has been in decline since December 21. There's no clear indication or signal to bounce back. However, small and emerging coins are probably profitable for active trading, right? And then what we did was to actually export the CoinGecko kind of like data into a CSV format, as well as we also created like a quarterly report on crypto. So this kind of like pattern might work, right? So I'm not saying this is the solution or the answer for how you use GPT and enterprise data, but it's probably one of them, right? So yeah, this is how we approach this at the moment with when we want to consider about enterprise kind of like capability level of kind of like query. The problem here still is that the limitation around here is that you still need to kind of like search back and back over and over again, right? Like it's still like it's like a meeting, right? Like it's still like, hey, this is a meeting that we're having at the moment, and like when you end the conversation, the meeting is ended, right? But it's not like a concept of like an advice that, hey, I know everything about you, and this is what you should be doing. So it's more or less like a conversation still, right? It's still a meeting. It's not a concept of like, based from everything that you have, do this, right? So it's not the answer of like, hey, I have $1,000. How can I get $1 million, right? So it's never gonna be that because you're still trying to retrieve information somewhere and just trying to put that in a writing, in a response. So the other pattern that's kind of like happening at the moment was that semantic kernel. So it's very new. So semantic kernel is similar to RAG, but it's more towards the .NET developers. I mean C# in particular. It's literally a lightweight SDK. The whole idea in it is that it's acting as a wrapper to actually do the RA, right? The RA and the G, right? So the whole idea was that using C#, I can have prompt templating, just like what we had earlier, wherein like, hey, I want to ground GPT that, hey, this is what the persona is. And then it also have the concept of function chaining, meaning like you can kind of like call different sort of kind of like GPT calls within it. And, it has vectorized memory and, intelligent planning. So that's kind of like promising. I've tried it. It's, questionably intelligent planning, but it is there. Yes, but I think one good thing about this approach is that it's a very bespoke kind of like solution instead of like going with Azure Cognitive Search straight away. So it's kind of like, hey, do you want anything that you want to do on your kind of like .NET kind of like code, like whatever really you want to do from that point in time until you respond to the question, you have that full flexibility and full capability on what it could be, right? So if you want to implement this, so it's just a NuGet package. So Microsoft that semantic kernel. So all you gotta do is create a kernel object. So then you have to pass in your API keys and stuff like that. Then you now create prompts. Then from there, it has different, from the kernel object, you now have a bunch of different methods to call, like Do you want to do semantic functioning, or do you want to do summarization? So, those kind of like different things, right? So again, a more bespoke approach instead of like going cognitive search, retrieve information, and like, talk to GPT and like give it to me, right? So you have that kind of like full flexibility around that. So how we kind of like experimented with it is that, so for example, you want to drill down on specifics about a specific company if it's a right investment for you, right? So like, because investment is a very complicated game. So one thing to look at is that how do you find indicators somewhere, right? So one way or the other, you can't really predict that. But for example, AI and Microsoft is kind of like big at the moment. So what does Microsoft use to assess its AI systems, right? So it answers saying that, hey, it uses impact assessments, blah, blah, blah. And like, what are it? Then if you did ask what are the requirements for impact assessment, then Microsoft is doing some responsible AI standards. And how many employees does Microsoft have according to the annual report? You see, this thing, because the advantage as well of doing semantic kernel is that you can actually chain public queries, like, if you want to use Bing APIs or Google search or like search through the web while also performing this kind of like LLM capabilities, right? So you have those capabilities. So you're not grounded, or you're not kind of like limited to just a specific boundary of a search, right? Or a knowledge base. You can actually mix knowledge base plus GPT plus the like the web, and also because it's .NET, you can hook up with any APIs out there. You can link it to a function. You can put event grid somewhere. You can use this and that, right? So a bunch of like flexibility on what you can actually do with this. Lastly, and this is kind of like I'm a bit biased because this LangChain is not really, well, first off, it's not very developer-ish approach, but at the same time, LangChain is kind of like just becoming the new buzz again. So when there's a buzz after a buzz, it's kind of like becoming more buzzy. So, but the whole idea of LangChain, right? And by the way, LangChain has nothing to do with, most of the time, nothing to do with Azure and Microsoft. It's actually an open source kind of like effort to kind of like solve the same problem. So, but LangChain is built around LLMs, but can be used for various purposes. So if people here have heard about AutoGPT, that kind of like does that, hey, instead of just doing one question, one answer approach, with AutoGPT, you can actually, like, it just keeps on and on and on and on, doing a lot of prompting until the task is finished, right? So that is the whole idea of LangChain, right? Like, instead of just like, performing one prompt and expecting one answer, and that solves the whole thing, the idea of LangChain is like you're chaining the language, chaining the different components of those kind of like prompts and response, and until you actually achieve the goal. So what does it mean for investment is that, and this is what we're actively exploring at the moment. We're in, like, let's say, hey, here's my portfolio. Strategically, where can I look at diversifying my portfolio for the next 2 weeks, right? So you can actually use LangChain to kind of like create that chain of thought reasoning of like, hey, this is the report yesterday, this is the report today, this is the report the next day. And like maybe, this is where you can kind of like diversify it based from your risk profile and your portfolio, right? So the whole idea of LangChain is it kind of like creates that, like a never-ending chain of prompting, that it just gets better and better in a way that it's, instead of, like, here's a big LLM of the world and here's a big data of the world. Now you're trying to really chain things together in a way that it, as more questions or prompts happen and more answers are happening, it becomes narrower and narrower, that eventually, all right, this is what you do. So next time when you ask it about this, it becomes more relevant now, instead of going through that whole cycle again of like retrieving information and augmenting, or like talking to ChatGPT over again, like creating a new chat history, right? So the whole idea is that it kind of knows the context as you go along, right? So that is LangChain, right? So it uses a concept of a Merkle agent. So if people are familiar with Merkle trees, and unfortunately one of them, because I dealt with blockchain as well in the past, and Merkle tree is kind of like big. Then you have the database and the internet, right? So that's basically like just creating a Merkle tree of your kind of like chain of thought reasoning, and with a source from the internet and a database of some sort, right? So the more Merkle tree it kind of like gets, that means that any kind of like new, more Merkle node happens, the more as you introduce a new question, it tries to search for the relevance across the Merkle tree before looking for the internet or through a database, right? So that's the whole idea. So you're kind of like creating your own index, right? So that's the whole idea of LangChain. Yeah, so like basic LLM prompt. And by the way, LangChain is in TypeScript and Python at the moment, I think. So there's no C# support yet. So like, give me 10 examples of companies that had successful IPO in the last 5 years. So, yep, there you go. So yeah, it did say Airbnb, Pinterest, Slack, Lyft, Spotify, and stuff like that. And then from there, you can kind of like chain it together further to kind of like, hey, tomorrow, and tomorrow, and tomorrow, and tomorrow, right? So that's probably one way of doing it, right? So in conclusion, where is this all going, right? At least from my past 6 months of playing with this thing, what I'm seeing is that it's more centric towards where your team capability is or where your kind of like team structure is. And I think that's kind of like what I'm noticing at the moment. Wherein, hey, if you're more on Azure or platform engineering route, like, and you have the proper infrastructure in place, with the whole knowledge search, knowledge base kind of stuff, maybe RAG is the way to go, right? Because that means that you have a concept of, business boundaries, service boundaries, infrastructure boundaries, network group boundaries, and stuff like that, right? And I think, yeah, RAG is like a top tier enterprise approach, in my opinion, right? Like, it's like, if you're working on the big enterprises and like big customers, RAG is probably the way. And that means it comes with the responsibility and capability that, hey, you need to have platform engineers who understands how this works, right? It's not enough to just have developers to do this. However, if you're more on a development focus kind of like a team, I think SK or Semantic Kernel is the approach, because you want more of those bespoke capability wherein, you want SK and extend it, put it on your Kubernetes cluster somewhere, and like, talk to Dapper, talk to this, talk to that, with event hubs and Kafka. So I think it's more centric around developer and like those bespoke kind of like customized approach. And lastly, if you're more on the data engineering route and like still kind of like in the self-serving way of the past with ML models, wherein by the way, one thing I want to say is that because of one thing that LLMs and GPT really, why it's so kind of like a big breakthrough at the moment as well, is because they've also changed the way we do MLs at the moment before, right? Because back then, if you work with like the Databricks and the kind of like concept of machine learning, right? Most of the time, the idea was that, hey, here's your data set, create a model, train it from that data set, and then you have a model, then use that for inferencing. And when you say inferencing, it is an API or a containerized API that the developers are consuming, right? Or feeding data and retrieving something, right? And then, hey, here's a new data from last week, then we just train it again, fine tune, like, create an inference somehow, right? That whole thing now has been disrupted, right? That whole concept of like ML ops capability has been disrupted. And now it's more around, hey, LLMs plus up-to-date information and, like chaining, right? Those are like the three emerging kind of like problems that you have to solve, right? Like, yeah, so that's why this is a very interesting space at the moment, because there's no clear winner on the approach yet. but at the same time, there's a lot of problems and like a lot of limitations that needs to be addressed. So that means that with LangChain approach, it's still more centric around like, hey, creating a proper Merkle tree in a data engineering sense, a very robust and very kind of like relevant Merkle tree for your organization or for your kind of like team structure. And that's a data engineering concept. It's not developer or platform concept, right? So that's why if you're more into the data engineering side, I think LangChain is also the way. But again, in 2 weeks' time, there's a new tool coming. So watch out. So happy to answer any questions. Yeah.
Yeah, so how is LangChain, how is LangChain different from the plugin support that ChatGPT is already providing?
Yes, good question. So the question was, how is LangChain different from the plugin support that ChatGPT is doing at the moment? So the answer is that LangChain is more centric around personalized use at the moment yet, in a way that you're creating your own Merkle tree as you go along. ChatGPT, on the other hand, they're trying to create an index of relevance. So that's like the main difference around that. So by the way, I forgot to mention that, the OpenAI, they're actually introducing this thing called GPT index, which kind of like another emerging approach on how to solve this problem. So yeah, that's like the main difference. Yes, sir.
Question is very related to that. So ChatGPT, you say it's more like generalistic in some way, and LangChain, you think it has a lot of potential in the financial industry because it's able to track more the changes that the questions are coming from.
Mm-hmm.
And finally, my question goes more, do you think like with the partnership that is happening with Wolf and Alpha, do you think like ChatGPT will become better with numbers? Because right now, it seems there's a lot of examples that is horrible with numbers, and that's pretty bad for finance or insurance.
Exactly. So the question was around like, where is this going, right? Is this more like, hey, here's ChatGPT, create a plugin, and like that is the app, or hey, here's LangChain, wherein try to create your own kind of like section of a slice of a GPT, right? So the answer is, to be honest, I don't know. But one thing I'm kind of like seeing, or kind of like seeing as a problem with the plugin approach is that, again, it's exclusive to ChatGPT, so you still have to deal with the public data. So one way or the other, if you want to put in investment advice, you have to put in your personal data in there somehow, right? However, with LangChain, it's kind of like focusing more on like trying to create a journey with you rather than creating a plugin or an application with you. So I think they're kind of different, right? So, and I think one way or the other, maybe in the future, the concept is like a modular GPT, right? Like a LLM with like multiple layers of LLMs, just like how you have multiple databases or data source at the moment. And then there will be one winner of the orchestration layer, aka the Kubernetes of this, who's gonna connect all of the dots together, right? On what is relevant to you. But right now, there is no clear winner who that orchestrator is.
If there's maybe a common service that offers all these small services.
I don't know. I don't know. Yes, Miligi.
OpenAI, the company, they said they're going to have business offering of ChatGPT. Do you know how different this is to something like Microsoft's own OpenAI stuff?
Well, to put it simply, right? I mean, again, first off, I don't work for Microsoft. I don't work for OpenAI. So this is purely on a perspective of someone working on using these technologies. So Microsoft, I think they really want to focus on the enterprise use case, those who are already in Azure, and like, the Dynamics, the Office 365, and like that kind of like data landscape. Now try to put in this OpenAI capability. It's not like you have to put all your data to OpenAI approach, right? It's more like, hey, you have your data, now let's leverage this as a new feature set, right, that you can kind of like use. But for OpenAI, I think what they're planning to do, or my perspective, is that, hey, here's public, here's private, here's enterprise kind of like approach, right? Like just like how you want to put in your SaaS solution, right? Like, do you want the public one, or do you want a private version of it, or do you want like, an enterprise tier of this? And probably the enterprise tier and the Azure OpenAI tier, there are probably a lot of synergy and kind of like a disparity as well at the same time. All right. Thanks very much. Anyone have any questions? I'll be at the back. So thank you.
That's all right. I've got one in the bag. I always get really hot when I'm once I start.
Maybe that's what we're doing. That's the design.
I think that's pretty common, isn't it?
Yeah.
I don't know. Where's the
Testing.
Yeah, it was. All right. Good morning, everyone. So my name's Bryden Oliver, and I'm going to talk about how we can build in Azure without the costs getting really, really out of hand. So first of all, I'll tell you a bit about me. Is it you having trouble hearing? Oh. Is that any better? Yep, beautiful. So I'm a cloud solution architect with SSW. I've worked with Azure since it launched. It's now almost 15 years. And I've had 20 years of experience in database performance issues. And really the reason I'm going to talk to you is that I learned an awful lot when I was working in these database performance things, where we were working with, at the time, the largest Azure Cosmos DB installation in the world and the largest Azure Functions. This was in the early days of both of those services. There's now much larger installations of those. But when we got going, cost became an issue, and there's an awful lot of things that go into thinking about that cost. So first we'll have a quick look at what are the problems we're trying to solve. Then we'll talk about how you might plan your deployment. Just a few simple points. Then some stuff about what's the easiest way to deploy, and then how we would monitor our costs once we've actually done that deployment. And then finally, how we can reduce that cost. If we've gone and deployed stuff and, oh dear, our manager's chasing us because we're spending too much money. Okay, so I presume lots of you here have Azure installation somewhere. How many of you know the cost? So how many of you know how much it's costing you roughly per month, say? So a few of you. That's actually more than I expected. How many of you planned how much it was going to cost before you started? Again, a few. And how many actually have active monitoring of how much you're spending and, you know, have to report up? Yeah. So even more of you have to do that. So that sounds like a lot of you went and built the thing, then you've had to work out what the cost was, rather than knowing what it was before you started and actually getting approval for that amount. And that can get scary if that number comes out way higher than you expected. And then here's the final one. What are you going to do if the cost blows out? Do you have a plan for if it costs 10 times what you expected? Do you know what levers you might pull, who you might contact? What are the things you're going to do if you have cost overruns? And Azure can cost quite a lot without planning. So this Cosmos DB installation I was running, we were sort of assuming we were going to run at about $50,000 a month US, and we'd be fine. At the peak, we were running at $250,000 a month and going, how are we going to get this thing under control? And it came back to having to think about what the architecture was, why we were using Cosmos, were we using it for its intended purpose? And the answer was no, not entirely, and moving some of the data we were putting into Cosmos elsewhere and reducing our costs that way. But the big mistake we made was we didn't understand how much our application was going to cost before we built it. We found it out afterwards. And if you do know what it's going to cost, the other thing that people get wrong, and I've seen quite a few of our clients do this, is they go and work out what it's all going to cost, they get approval, and then they deploy something different. And then go, well, the cost's different. Why? Well, I intended to use 4 core machines and I spun up a bunch of VMs with 16 cores. It costs 4 times as much. And it's very easy to do because it's just one number in in your deployment script probably. And that's the only mistake you've made, and yet it's quadrupled your cost. And the other thing is, as we're building it, make sure you are watching how much it costs so that you can keep track. Okay. So that was a bit about an introduction to some of the things we'll cover. Now, the big thing a lot of people don't think of is they think when they're building in the cloud that the Azure bill is everything. That's the only cost building in the cloud. But it's not. You'll have other infrastructure. A lot of people use things like Cloudflare, say HubSpot, all those sort of things, and they're extra costs. You'll have a few SaaS vendors providing you little pieces of the puzzle. Remember those costs. But the next one, this is typically the big ticket one that people forget, is you're going to employ some developers to develop that software. And that's going to cost probably, in most cases, unless you're running at enormous scale, it's that development cost that costs you the money. So it's the upfront cost of having the software and application is what's going to cost you the money, not the ongoing Azure cost. So remember that that's something you should consider. And then finally, there's the ongoing support costs. So as well as paying for Azure, so you're paying Microsoft for that, typically your application is going to require support of some sort, whether that's one inquiry a month from a user who's having a problem or daily, there's hours and hours of support engineer time spent on your application. Remember to think about what you're going to expect with that and perhaps designing around minimising that cost. Because in my experience, it's actually the development costs and the ongoing support costs that are the big ticket items. So let's have a little, and actually I almost missed the opportunity to talk about opportunity costs. So this is where if you're building a highly complicated application rather than starting simple, if your business sees another opportunity and it's still halfway through trying to build its first application, you can't chase that second opportunity and potentially you'll miss an opportunity. And this is what startups tend to do, is they'll go and build out as they intend to scale. So they'll build it so that if they get 100,000 customers, I don't need to modify the application as I grow. But in building, that means it takes me a lot longer to build the thing in the first place, and therefore I missed an opportunity. If there's something just adjacent to my market and I haven't hit the first one, I can't then pivot, grab some revenue there, and then scale up once I've got lots of customers who are then paying me money, which now means I've got staff to be able to do that scaling. So one of the biggest things in cloud infrastructure, and this is this is something that you didn't really see so much on-prem, is there's this sort of distinction between a managed service and an unmanaged service. So what do I mean when I say a managed service and an unmanaged service? If we look at, say, Azure Functions under a consumption plan, that's a managed service. All I do is write some code and deploy it. I don't create a VM, I don't create any operating systems, I don't maintain any of the security of that. All I do is supply the code. Microsoft does everything else when I deploy that. That's highly managed. Unmanaged is I want to deploy a website or a web API endpoint. I build it, I go and get myself a VM, I install the operating system I want on it, I install the web API on it, and I run it, and I maintain all of the network rules and the firewall rules and all of that. That's an unmanaged service. That's you having to do all that work instead of Microsoft. So in a small company, I would, and almost always, even in larger companies, I tend to move towards the managed service. Particularly here in Australia where salaries are high, managed services make a lot more sense than the unmanaged services. And the thing with the managed services is it reduces your long-term, as well as it reducing your initial development and deployment costs. It generally means a lot less work to maintain. So those ongoing support costs are way lower if you pick those managed services. So that's the first big sort of decision point you get when you start designing solutions in the cloud, is whether to go for the managed services or the unmanaged services. And typically, in my view, the higher you're going to scale and know you're going to have to scale. So if you're someone like, National Australia Bank, they know they're going to have to scale really high on transaction volumes for, say, a transaction system. They should go for an unmanaged system because the cost of that is peanuts to them. Whereas if you're expecting like 100 customers, you don't want to be managing everything. You want to have someone else do that, and they're charging a small amount, but you're not having to have DBAs or system administrators about extra to your day-to-day activities to do that. Okay. I mentioned Cloudflare, Hotjar, HubSpot. There's all of these systems that people typically tack on to their large applications to cover little bits of functionality that the cloud vendor doesn't provide, or they don't provide it nicely. So remember, you're going to have all these little costs. Other ones, common ones you see in enterprise applications are things like DocuSign for signing documents. If you're getting people to sign up to a contract, you'll have something for that. And, all these little things add up. So make sure when you plan out your applications, you actually include those and go and do a bit of research on how much each of those things you think you're going to need in your service is going to cost. Okay. The big thing with the initial development cost is your development does cost money, and development certainly in Australia does cost quite a lot. It's not cheap. Staff costs are high here. So you do need to be mindful of that initial development cost. And that's primarily staff time, but you've got rent, office, equipment, internet, all of those costs come into it. But when you're budgeting this, I advise don't be exact, just come up with a realistic estimate. For typically, if you're developing in Australia, I find that $2,000 a day for running a developer is about accurate. It's a little bit high, but it's not outrageously high once you factor in all of those extra things.
Sorry, is that per resource?
Yeah. Yeah, it comes out to about that. I mean, that's assuming they'll have a manager and you're paying for a bit of that. But it's a good estimate. It's not super accurate, but like if you're saying I'm spending 100 development days, you know, it's ballpark to then compare to your Azure cost, which might be, so say it was 200 developer days, that's $200,000 upfront. If the Azure cost I'm expecting is $1,000 a month, I don't care about it optimizing my Azure. I care about optimizing my development time, in which case I'd go for the managed services. However, if it was the other way around and the Azure bill was going to be $200,000 and my dev costs were going to be $10,000, I'd go, maybe I'll go a bit more unmanaged, even though it's going to cost a bit more upfront and a bit more in ongoing staff time just to get that Azure cost down. Because that's typically the biggest lever you've got, is how managed it is, drops your Azure cost. And so it's like a needle. You pick how much you want to drop your cost in Azure, and typically your staff costs go up as you do that. And of course, the ongoing support costs, again, it's staff time. Again, it's, you know, somewhere between $1,500 and $2,000 a day, roughly. You can probably get a more accurate estimate for your company or organisation, but the hard thing here is try and plan how much is needed, and it's kind of hard to do that. That's really the big unknown, is if you have a lot more bugs in your software than you expected, that can blow out. But, you know, for most applications, if you've had your organisation build several applications, you'll know roughly what the ongoing maintenance type numbers look like. And maybe you can reduce them by going for a more managed service than the last one, or you know you want to go, you're now building up a lot of in-house infrastructure expertise. Okay, we'll start managing the infrastructure ourselves and go to an unmanaged service. And the ongoing support costs, that's typically where, if you've gone unmanaged over managed services, that's where it comes back to bite, is in the ongoing support costs. And the missed opportunity costs, I really sort of cover that off, but if it takes a lot of time to develop stuff, you're going to miss other things you could do with that time and those resources. So, yeah, and the other one is, if you require lots of support for the application you've deployed, you're also you're unable to go chasing new opportunities because you've got so many staff tied up in support. And that's a very big one for sort of small startups. They tend to get trapped in this, we can't go chasing that new opportunity because all of our devs are tied up keeping the thing we've already built and got sort of running. So one thing here is, this is sort of moving on from that your architecture typically does matter. Like, do you use a relational database, or do you use a document store? Typically, they have different cost profiles. Do you use something like Synapse Analytics rather than a relational database for your data warehouse if you've got a data warehouse or data lake? And the reason you might do that is with the sort of relational databases, typically you pay for storage and compute together. So you're paying for a CPU and some storage at the same time, and you've got to pay for both of those all of the time that you have that resource. With something like Synapse Analytics, you pay for them separately. Your storage is typically is blob storage, so you're paying for your storage there, and you pay for however much of that you use. And then when you want to process some data, you spin up some compute, run the compute, and if it's a bulk load, you can spin up a big compute, run it, switch it off. You don't get that opportunity with the relational engines as much. So that can save you enormous amounts. And in fact, that's how we solved our problem with our Cosmos installation. Was Cosmos, we were effectively paying storage and compute for both, and we wanted mass storage, but we didn't want much compute. So we moved it all into blobs, well, the majority of the data into blob storage, and saved on all of the compute. And in fact, it was the compute that was the big cost. Okay. Typically, the more managed services work better for you. That's just seems to be particularly in small startups or even to small medium enterprises. It's really only the larger enterprises I commonly would recommend that they consider an unmanaged service. Okay, the other thing that's important to know is your business might grow. So have an understanding of the solution you've got and how it will scale. So different services, they scale in different ways. So for instance, Azure Functions on a consumption plan scales in a straight line. Every function execution effectively costs a fixed amount. So every time, if you double your customers, your cost doubles. But if you've got something fixed, like I've deployed a virtual machine, it can take 100,000 requests a minute. If I'm only getting 20,000 now and I doubled 40,000, my cost basically doesn't increase. So that's a fixed cost. So as I scale, I don't need to add more until I hit that 100,000, and then I've got to think, but am I going to hit that 100,000? How many years have I got before I hit that 100,000, or months or days? And the key one is make sure you understand how they scale. So services can scale in different ways. We've been through those ones. The other one is Microsoft, for a lot of the services, offer a dev test plan. So, and the other one is your development and test environment. You may have a different cost profile to your production, like you may have it much smaller and therefore it doesn't hit a scale out or something. So be aware that you might get a sudden shock when you go to production because you're going to scale out further. So it's worth running some testing before you do that. In my view, if you're starting small, start on consumption plans. Like Azure Functions consumption is a great way to start sort of API-based development. Things like Azure SQL database on the smaller plans is great for getting started in if you need a database, or as Cosmos DB on the bottom serverless tier, things like that. That means you can grow and it costs you almost nothing until you do grow. The other one is Azure reservations, which if you know you're going to run this service for more than a year, you can take out, say, I'm going to pay for this for a year and pay in upfront installments, sign a contract, and you can save up to 55% on some of the services if you sign for 3 years. You say, I'm going to use 4 VMs, I can get a 55% discount by signing for 3 years, that I'm going to continue having those. So that's another way to drive costs down if you're in an enterprise where the scale is going to remain, is definitely going to grow or stay stable. If it's going to go down potentially, that's a bad plan to sign up. Okay, so someone today is going to talk about infrastructure as code. That is great. That makes this repeatable, so I can then deploy the same thing into a test environment. So do that. Make sure you build the deployment with parameters, so potentially you can change to using smaller scale in your dev and test environments. And there's one set of doco there. Keep an eye on that. Yep. Look at using smaller deployments for dev and staging. And be aware with deploying smaller, some features won't be there potentially, because as you go down the tiers in the Microsoft things, typically you get slightly less features. And you can check the detailed pricing page for all the services for that. The other thing to do is verify the cost after you deploy all your static assets. And you'll need to finish your app to verify that the dynamic costs, but you can verify that the static things like my virtual machines are actually costing what I expected. Okay, so let's have a quick chat about monitoring. And to start with, I just set a budget in Azure Portal, and typically that's good enough for the customer. So I just set that 50% above what they expected, or a nice number above what they expect, so that if something's really running over, there's no problem. And now we'll have a quick chat about how to reduce the cost. So typically there's a fixed component in how things will scale, and there's a usage-based component. So some things will be fixed and won't change as you grow, some will. So try and understand which bits of your cost, when you analyse it, are either. Remember, it's going to take effort to reduce cost. Think about how much time you're going to spend on whatever your cost-saving efforts are, and how much does that time cost. And this is what I see a lot of businesses do, is they don't do these first two. They say, I want to spend a week reducing our bill by $100 a month. And I've had customers where I went back to them and said, the return on investment on that cost management exercise you just did is 20 years. So it was completely pointless reducing their costs, because they actually just increased them, and they've got to pay that for 20 years regardless. And they've actually paid it up front because they spent people's time on it. So think about what the return on investment there is. The other one is, if you go into Azure cost analysis and have a look at how much you're spending, look at your biggest three costs first, and typically don't go any further than that. That'll be at least 75% of your costs. That's where to spend the energy, just looking at those. Too often people start on the small one, go, that's going to be easy, and then spend a few days reducing like a couple of dollars off the end. They haven't looked at the big ones. So if we use Azure cost analysis, it's great for this. So this is what it looks like. So have a jump in there. So here's the tips on what you can do. If the costs are static for whatever it is you're trying to reduce, do we need the number of things we have? Can we reduce the load on those instances and therefore we need less of them? Can we just reduce the number of them? Can we move to Azure reservations? That's another, as I mentioned that one before. If they're dynamic, we have a lot more scope to reduce costs, because every transaction or billing or execution costs money. And be aware that the dynamic costs won't be linear. They will bounce around a bit. There'll be scaling inflection points. So do some scaling tests and understand exactly how far you can scale. So there's a few things to be able to figure out what those are, things like App Insights and Profiler. And just figure out where the costs are coming from, and be aware that it's quite often one feature that someone's insisted on having, and that maybe that feature isn't worth how much it costs. The other one I'll mention is application insights is often a huge cost, and very often it costs more than the solution that it's monitoring. So set the scaling on. You can use sampling to reduce down as your application insights costs. I've actually run out of time. There was a little bit more content, but anyone who's got further questions, come and see me during the lunch break. Thank you very much.
Hey everyone, can you all hear me okay? Okay, so thanks Brian and Flat Talk. That's a great lead up into my presentation. So my name is Rodney Joyce. I've been coding for a long time, using .NET since it came out in the year 2000. I'm the managing director of a company called Cloud Monitor. So we've been helping companies lower their costs with our open source FinOps tool. And we basically help customers understand their costs. We have a real-time alerting, the Teams bot, and it's all open source, so you can take it and extend it for your organization, and it runs on top of Azure. There's a QR link on the right-hand side or the left-hand side if you want. And this is the kind of report you get, very nice, white-labeled by business unit, etc. Okay, so first of all, who here knows what FinOps is? Okay, that's like a really small amount of people, and that's good. So when I started this presentation, I was going to do more about Azure, but then I decided that after talking to a few people, there's not enough awareness of what FinOps actually is. And Bryden's already covered, actual implementation details. So I'm going to focus on what FinOps is, exactly like DevOps, but it's FinOps. So who here thinks that FinOps is about reducing costs? Okay, that's a trick question. It's actually not. It's about improving business value. And I'm gonna take you through why we need FinOps by looking at the problems. Okay, so first of all, why are we on the cloud? We're on the cloud because it gives us PAYG scaling, which enables innovation, rapid application development. We can access services like OpenAI at a fraction of a cost than if we had to build it ourselves. However, that comes at a price. So, for example, imagine that you're the IT manager of a big organization, and your CEO or CIO or CFO comes to you and asks you these questions. Which business unit should a cost be charged to? How much does it cost to operate a given application or product? How much revenue did that product earn for the business? Which services can be switched off in production? And how much will a data platform cost in 1 year's time, i.e. predicting the price? Now, I guarantee these are very difficult questions to answer. So we haven't got this link between business value and revenues, cost spend. Now, if you look at why costs spiral out of control in the first place, the number one issue is visibility on costs. So right at the bottom, we've got developers who are creating resources. Every single developer is making a micro buying decision with every resource that they spin up. That resource they renting for a period of time has a cost impact and even a carbon emission impact, but more on that later. So it's amazing when I ask the developers on my team, or I'm doing interviews and I ask people, so what database tier are you running on? Or what was the app service size? And they just don't know. The cloud's abstracted so much away that a lot of developers are not even taking or paying attention to the different tiers. If you use the CLI, sometimes it just defaults to a SKU that you didn't intend to. But it's amazing how few developers are actually aware of the cost that they're generating with each choice they make. If you move up a level to the business unit owner or the product manager, they're the people that are in an organization and they want to balance the features that they're asking for with the business value that it's generating for the cost that it's spending. Now, what happens is they go, the CFO comes to them and says, how much is your product costing? They go to IT and say, please generate a report for this product. And IT go, well, what's your product? I know nothing about it. We're a big organization. So someone has to work out, okay, it's this resource group here, this subscription in production, there's a common subscription for the data warehouse, we're going to share that cost there. Someone has to do all this calculation for 100 different products in the organization. But you have to get IT involved, which immediately slows things down a bit. Sorry, all the IT people out there. And then you go up a level further and you get to the CFO. Now, he receives this bill once a month with this itemized line items, things like egress report 1 minute. And he has no clue what that even means. All he wants to do is work out who in the business he has to go to and say, you owe me this amount of money for the consumption that you generated or the spend that you generated. So he needs to be able to charge back that huge bill, slice it up and go back to the different product owners and say, you owe me this amount for your product that should have generated this amount of revenue for the business. So if you cannot allocate every cost, you end up with this bucket of unallocated costs, which is essentially wastage because they don't know if it's providing business value or not. Second problem is this disconnect between the resource creator, the technical engineer or the developer, and the bill payer, the finance team. So they speak in different languages. One's technical, one's business. They don't know each other's terminology. There's also a time delay. So from the moment someone spins up a database, the bill might arrive 6 weeks later. It's very hard to map that spend to that action. And there's a general lack of governance in the cloud. This is probably the root of all evil in the cloud. So simple things that you'd expect, like when was a resource created, who created it, and why they created it. It's amazing how little governance there's in the cloud. Now, many companies are not budgeting for optimization. And I'm going to tell you a true story. About 3 years ago, we were doing a data platform in a large government organization. And while we were doing our work, we noticed another data lake on the side and was costing $500,000 a year of taxpayer money. And we looked around and I said to the product, and I said, listen, I reckon I can lower this cost by quite a bit. So he said, okay, go for it. And he approved a 2-week budget. And in 2 weeks, we dropped the cost by 120,000. So 22% in 2 weeks. And I published a report, and so one of the case studies on Cloud Monitor, But we couldn't get any attention beyond our product group. Like, we could have gone to the whole organization and say, we can lower your costs by, $1 million or $2 million if you just empower us, give us the budget to do this. But this is one of the challenges in FinOps, is that we're attacking this from the bottom, from a technical lens, whereas you need to come from the top, from the CIO or CEO, and empower your company to optimize your costs. Now, I'm slightly skeptical, but all cloud vendors, their core business is Azure consumption revenue. So it's not really in their best interest to be too helpful when lowering your costs. So, for example, Azure's got some great features like budgeting. However, it's not turned on by default. Who knows why? It's like it could just be turned on and give you a default and you could adjust it, but it's not. And it's really aimed at technical users. So there's amazing APIs in Azure. There's cost allocation, there's the great reports, but they're all aimed at technical audience. So no product owner, no business unit user, no CFO I know has ever logged onto the Azure portal and lived to tell the tale. They just do not use that tool. So we're missing a whole interface for business users. And the alternative to that is that they have to go to IT and say, how much does this cost? Which immediately creates a problem and a communication challenge. So tagging is the current best option that we have here. Now, tags are a name value string pair. They're fairly useless unless there's a process enforced around it. So, for example, I could say, okay, we're going to say created by, and I'll put Rodney in there, and then the next person comes along and types created by without a space, next person puts a dash, next person uses uppercase, and you suddenly got 4 different tags. There's no semantic value to a tag. If I leave the business, Active Directory doesn't know that I've rolled off the company unless you have a process, a human process to go and follow that up, or an automated process. Now, if you can't tag data, it's very hard to allocate costs back to that business unit. And I'm going to use my own developers as an example. The guys that wrote Cloud Monitor, our FinOps product, these guys are smart. They still leave the Databricks clusters running. And this has got a joke in our team, because I have to go back to Microsoft and beg for forgiveness and get a credit back. And these guys are smart. So humans make mistakes. And the best we can do is catch these mistakes as soon as possible. And this is where we need real-time alerting, cost anomaly detection, and the ability to understand those cost changes as quickly as possible, and very granular reporting. Now, bear in mind, the same developer who can't use a company credit card to buy a cup of coffee can spin up a $2,000 Databricks cluster. How does that work? Okay, so the root cause here is that the cloud is variable spend by nature. So you're using capacity as you need it. Therefore, it's very hard to predict how much you're going to use, and it's very hard to budget for. So all of these problems contribute to spiraling out of control costs. So when did this happen? It was the move from data centers and on-prem onto the cloud. And bear in mind, I went over the benefits of why we use the cloud. We all agree we want to get off the data centers and on-prem. We want to use the cloud. The developers love it. The CFOs not so much. So in the data center world, we've got CapEx. The dev team are running SQL. They hit a barrier. They want a new product. They go to the procurement team and say, we need a massive $500,000 server. It gets approved, takes 1 month. Server gets delivered into the data center or gets purchased, and away they go. So there's an approval process. In OpEx, no one's approving that cost. Just like the developer spinning up a Databricks cluster for $2,000. No one's looking at it. And if he's lucky, no one notices that $2,000 cost anomaly. And it's purchased by engineers. And no approval is required in the cloud, where it's required in a data center. Now, in a fixed capacity world, if you reduce your consumption, it doesn't make any difference. So there's not much incentive to do that. Whereas in the cloud, if you reduce your consumption, you're actually saving money. You're actually making profit for the business by reducing consumption. And because you pay up front, it's very easy to predict the budget with data center world. In OpEx, it's very hard to predict because you haven't spent it yet. You're actually predicting usage capacity, not cost. So in the data center world, you do not need frequent reporting because part of your budget, it's a line item on your balance statement. Whereas in the cloud world, you need that really granular reporting because costs vary hour by hour or second by second even in real time. And you also have multi-cloud challenges. Okay, so what's the solution? A new operating model is required. Now, it's got a name. It's called FinOps. This happened about 3 years ago. So we've always been doing some of these kind of things without realizing it, but now it's got a handle and it's got a way of implementation. I'm going to read this description verbatim from the FinOps.org website. So Cloud FinOps is an evolving cloud financial management discipline and cultural practice that enables organizations to get maximum business value by helping engineering, finance, and business teams to collaborate on data-driven spending decisions. Now, it's a bit of a mouthful, but if we analyze what they're saying here, so it's evolving. They're not saying this is it, we're done. It's continually evolving, the practice, the operating model, everything. It's a cultural practice and a discipline. So it's not a process you can turn on and that's it. It's something you have to, just like DevOps, you've got to actually educate everyone why a DevOps first approach makes sense. There's no immediate apparent value, but the long-term benefits over time are huge. So you have to make that shift in your organization to become a FinOps-aware company. You're not lowering costs. You're maximizing business value. Spending $1 million is great if you're going to earn $5 million for the business. So it's about maximizing business value, not reducing costs. And it's a cross-functional team problem. So you've got to try and get the engineers talking to the business, talking to the finance team. And that's why it's so challenging, because you can't just empower one team because the other teams won't listen. You need to come from the top and empower them. And by doing all of this, you get the ability to make data-driven decisions, educated, information-empowered decisions. Do you spin this up for more business value? Do you spin this down, etc.? Okay, so the FinOps Foundation is a cloud-agnostic, open-source, public domain entity that is part of the Linux Foundation, formed in 2020. Now, we're in no way associated. It's just a really common sense platform that makes sense. It's got 9,000 community members around the world, 9,000 certified FinOps practitioners. I'm one of them. And that represents 3,500 companies. So these guys get together in working groups and they discuss things like, okay, what are the challenges that we see in organizations and enterprises? How do we do this? And over time, they've built this framework. Now, my opinion is that there's no ways I'm going to go and reinvent the wheel, and I can't compete with 9,000 different data points. So I'm going to introduce you to the framework. Okay, so the link's on the slide if you want to check it out. As I said, you don't even need to log in to see the framework. So if you want to implement a FinOps culture in your organization, this is how you would start. First of all, we look at the phases of FinOps. So it's a continual cycle. It never ends, and you can actually start anywhere. Every organization is different, depending on the workloads in the cloud, the education or the skills of your team. Are you a SaaS product? Do you have DevOps? What does your CEO think? Does he read the CIO Weekly magazine? There's 101 different variables that influence the maturity level of the organization and where you would start. If you're not sure, start in an inform phase. So inform is all about understanding your spend, ensuring your cost allocation and tagging and governance is correct, and starting to measure what you are spending. Now, there's 3 different levels of maturity that the FinOps Foundation has defined. There's crawl, walk, and run. So again, there's no fixed pattern here. You don't have to go into the inform phase, get to the expert run level, and then move on to the next one. You do whatever you need to suit your business. There's great open source assessments on the website of how playbooks on how to do a FinOps assessment. How do you analyze your organization's current state capabilities and map where you want to be, and how do you get there? So after inform, we move to the optimize phase, which is all about lowering costs, making sure you're getting the best prices for your services, leveraging the bulk buying discount of your company, et cetera, et cetera. That's actually the more fun phase if you're a developer or engineer. That's where the engineers get involved. And then operators implementing those changes, measuring them, being able to demonstrate business value for what you're doing. Unfortunately, it gets a lot more complicated than this. It would be nice if it was just that simple. So there's 6 key principles in FinOps that the working groups in the organization have come up with. So teams need to collaborate. This is not a technical issue or a finance issue or a business issue. It's all 3. And that's why it's so difficult. We know that for a fact in a business. When at the moment you have to talk to another department, everything just slows down. Everyone takes ownership for their cloud spend. So right down to the developers, you're delegating and pushing cloud spend responsibility down to the edge, and you're saying, if you choose to spin up a Cosmos DB, you're going to pay for it. That's coming out of your budget. So now the business owners and product owners start to think, okay, I now have to balance cost, performance, I forgot the third metric, quality, we'll call it, and they have to make a conscious choice on spend. But there's a central team that sits across the 3 different areas, finance, business, and engineering, that does a few things. Number 1 is they leverage the buying power of the whole organization to negotiate better rate discounts with the cloud vendors. So we were in a customer a few years ago doing a Databricks implementation, and we found out that another part of the business already had Databricks, and they had a reserved instance of Databricks. But we couldn't use it, which is ridiculous. If they'd had a centralized FinOps team, they would have said, okay, there's two guys in our company that want to use FinOps, 2 products, get a better discount negotiated with the cloud vendor, and then distribute that out to the teams. The FinOps team is also responsible for evangelizing about FinOps and keeping everyone accountable. Now, in order for FinOps to work, you have to have accurate reporting. So they have to be timely and accurate. Now, if you've ever used the APIs in Azure, you'll know that there's a 1-day granularity. You currently cannot go down more to the hourly level. I think in AWS you can. That's something that Azure are working on. But yeah, so basically you want to report at least daily in Azure. And all of this gives you the ability to make decisions which are all about business value, and allows you to take advantage of the variable nature of the cloud. Okay, so now it gets a little bit more hairy. We've got 6 domains, which are like categories, and each domain has capabilities. I won't go into this into too much detail because it's a little bit too much content. But basically, if we think about the first domain, which is understanding cloud costs, under this, there would be things like ensure your tagging is correct, ensure your reports are at the lowest level of granularity. And you can get all of this information on the framework. And again, we've got this concept of crawl, walk, run. So if we use an example like reporting, an example of crawl would be, I do quarterly reporting on my cloud spend. An example of walk would be, I have the ability to get reports at a daily level. And run would be, I have the ability to report at an hourly level. Now, obviously, that curve grows exponentially as you get closer to run. The effort and cost to implement that is a lot higher. So a lot of organizations move between these different domains in the order that suits them, and they're at different maturity levels. They could be better at some things than other. There's no fixed pattern. And you can start these domains in any order as well. But this is just kind of the general gist of it. The second domain is performance tracking and benchmarking. So you want to prove to the business that your FinOps team is increasing business value and justifies the result that they're spending on the team. So you want to set up your KPIs. You want to be able to measure your unit economics. So for example, is the product that is running for X amount of dollars, is it bringing in more revenue than it's running for? What's the cost of acquisition per customer, etc. Everything has to be in real time to catch the anomalies as quickly as possible. Cloud rate optimization. This is about negotiating those rates for your reserved instances. So reserved instances are the easiest way to save money in the cloud. So it's basically a pre-commit to spend a certain amount over a fixed period of time, 1 year or 3 years. You can get it for Synapse, Databricks, storage, VMs, etc. There's also compute savings plans in Azure, and all the other clouds have their versions of this. Compute savings plans are way more flexible, but they have a lower cost saving. So RIs, reservations, work well when you have a very predictable workload, and you can predict the next 1 to 3 years of cost. So that is the easiest way to lower your bills. And then cloud usage optimization is what Brian was talking about, where it's like you go in, you push down to each team and you say, you're now responsible for your costs. You're accountable for your costs. So make sure you optimize your product. And that's the really fun stuff. That's what I actually enjoy doing. Not so much all this other stuff. Organizational alignment. This is making sure that everyone in the organization understands the objective of FinOps and getting that cultural discipline that I mentioned earlier. You often need the buy-in from above. Now, there's 5 different personas involved in this, and I've given you a hint to them already. There's the FinOps practitioner who's evangelizing about FinOps and making sure that everything's on track. There's the C-level and execs, and you often need their buy-in to start this off. If you do not have this, it's very hard to get a FinOps practice going or a FinOps culture. They're also going to make sure that the objectives of the FinOps team align with the organization's strategy. The product owners are now balancing speed, cost, and quality. So if you think about cost, it's often a non-functional requirement. Someone will say to you in your weekly sprint, if you're a developer, they'll say, okay, we want this new feature. It's a bit slow. The first thing the developer does is scale up, doubles the size. Someone else will pay for that. They meet their sprint objective, everyone's a winner. The CFO gets the bill 6 weeks later and has a heart attack. So now the product owner has to say, okay, I want this performance, but it's going to cost me X amount from my budget. So now it becomes a business decision. Do you scale up or not a technical decision. The engineering team are now more aware about the costs that they're spending and making informed choices. And the finance team still paying the bills, but now they're clawing back that money that's being spent, and they're happy. As long as they get their money back from different business units, they're happy. It's up to the business units to ensure that they are financially viable. It's not the finance team's job anymore, and they have lower wastage. Okay, so how to get started? I can talk about this all day, so I'm going to really try and condense this. I recommend, if you're interested in FinOps, and I think everyone should have at least a basic awareness, just like everyone should understand DevOps, even if you're not a DevOps engineer. Go to the FinOps.org website, have a read. If you want to get involved more, do your FinOps Certified Practitioner exam. It's $400. It goes into detail on the stuff I've just mentioned. It's really interesting, actually. And you get access to the Slack channel of 9,000 people. We're having these amazing conversations about, it's not just Azure. Azure is actually the least represented there. There's some really crazy conversations. I'm on a working group, for example, where I meet with the head of Azure cost management, the head of Google cost management, and we're trying to do a common billing standard across the clouds called Focus. And we meet 3 times a week to do that. So there's some great projects going on, lots of good knowledge. So to implement it in your organization, start with the C-level guys, present a business case. Now, when you make your business case, you can't go and say, I want $1 million to start your FinOps team. You have to go into something small and say, my objective is to save the business $200,000 over the next 6 months. So something measurable that can be measured. Present a business case to your C-level, get buy-in, and they will empower you. If they do not empower you, move on. Create a cross-functional FinOps team. So I've mentioned how that works. You take representatives from each of these different areas in the business so that everyone has a skin in the game. Define the goals. Again, you have to measure to be able to optimize. And then implement the framework, the FinOps practices that I've showed you. That will require you going down to a lower level of detail in those different domains and capabilities, and then measure and repeat. Okay, I'm going to take questions. So I'm well ahead of schedule. Actually, I'm not. I'm on schedule. Any questions?
So that cycle that you mentioned about, how many times or how frequently it should the iteration could go through, like quarterly or every month?
Okay, so that is a really good question because I didn't mention that. It's infinite. It's never finished. So FinOps needs to be embedded into your company and your team forever. It's never going to end because you're always going to have new resources being spun up and new resources coming in, human resources. So it's never ending. You'll find that your FinOps team will change focus. There'll be the low-hanging fruit, which gets massive gains, like that 120,000 we saved in 2 weeks of work. But then it becomes harder and harder to save money. But your business is way more efficient. So there's no velocity defined. So what I would recommend is you get to the core level of reporting, get to the core level of optimize, get to the core level of operate. But first understand the whole domain by doing an assessment. And then you iterate as fast as you need to and as fast as you're enabled to do so. There is no right or wrong answer. It's whatever makes sense for your organization.
And I have another follow-up question.
All right. Good afternoon, everyone. I hope you enjoyed the lunch. So I'm Andrew. I'm from Progress Software. So I'm not sure whether you heard of us before, but we're a company that's been around for more than 41 years. And if you are a .NET developer, the Telerik Studio is part of our product offering. So you might have heard of that or you have used that before. So for today's demonstration, I'm just going to talk about Progress Software, one of our products called Sitefinity, and how it actually can integrate with GPT for content generation. And then I will go through a little bit about Sitefinity Cloud, which is our content management in the cloud with using Azure to host it. All right, so like I mentioned earlier, Progress Software is a company that's been around for more than 41 years. We have quite a number of products on hand that we actually help developers to do their technology improvements. These are just some of the numbers from our end. Our products are actually white labeled to organizations like Oracle, Microsoft, Google, for them to use on a daily basis. So, for example, if you are using things like Google Sheet, you might be using some of our products indirectly. Now, so for today, I'm going to talk about Sitefinity, which is our content management system. So for anyone who has a website, you probably need a CMS to manage your content. And Sitefinity is one of the products from us that we actually help with that. So in this year's Magic Quadrant, we are ranked together with our competitors, and that's a good thing because that actually helps you to sell if you were to choose a good product to use. Then one of the reasons why we are actually pretty good is because we actually helps users to deliver content on an omni-channel engagement, meaning you can have one source of content and you can use the same content for your web, your mobile, your kiosk as well. And it's easy for marketers and developers to use this product to go to market. And also, we also provide personalization out of the box with our Sitefinity Insight solutions. So let me quickly jump to what I want to demonstrate today in terms of the offerings. Give me a second. Okay, before I go on, my legal team actually requested me to just flash a disclaimer in the sense that for today's demo, it's a proof of concept using GPT. And if we were to offer this in future as an offering, the licenses or GPT license will have to come from our end users. And last but not least, as per GPT goes, if the content comes back from GPT, it's not ideal for presentation, or we are not liable for any of those things. All right, now moving on. So, like I mentioned, Sitefinity is a content management system. So once you log into a content management system, the first thing you do is, of course, you want to create a content. But as you know, nowadays with marketers who are using GPT, you basically need to provide a prompt, get the GPT to come back with the relevant answers that you need. And then from there, you copy and paste and put it into the website. But what we have done as part of the demo or proof of concept is the ability to use our own native chatbot, basically through a prompt. So for example, I want to create a landing page about a certain topic, promote a gated resource, basically a white paper, choose the white paper option here, and I basically can choose any topic that I want to do. So maybe I want to do personalization for the masses. So as you can see, this is actually a live demo. So it actually goes out to ChatGPT, and my target audience is probably the marketers. Do I want to create a personalized version of this page? So traditionally, if you want to create a personalized version of this page, you got to redo the entire page again. But in this case, I just choose yes. So from then on, the system actually will integrate with Azure functions to go to GPT using the API, then collate all the content from the cloud and create the web page inside Sitefinity itself. So this actually saves you time from having to actually copy and paste the content from GPT again. So actually it's still in process. So it takes about a few seconds more. Now Sitefinity Cloud is actually hosted in Azure. So what this actually comes back to you is once you do this, your data residency can be in any of the Azure data centers. So if your client is actually based in Australia, then you can use the Azure data center in Australia. Or if you are India or Singapore, you can use the respective data centers as well. Then from then on, okay, what you can see here is that GPT has come back with the content. It has created a page for you to edit. So let's go load it up. Now, Siphoninity is actually built on .NET Core and also MVC. So what you see here is basically the .NET Core version. And what my system has done is basically using the GPT content, come back, create a template, create a page using the GPT content, basically over here. And then the subtext over here, create 3 bullet points for me. And then all the standard blurbs as well. Now, at the same time, you actually look through all my past blog posts and chose 3 that is more relevant for the idea that I want to disseminate. Now, remember earlier, I did ask it for a personalized version. So what it does was actually created a separate version for the marketers as well. So the content is actually different. So in this case, what I'm going to show, what I've shown you is basically using the ability for the CMS, the Azure functions, the GPT to create a page for you that you probably need a few hours to do. So all these are done within 5-10 minutes. Yeah, any questions so far? Yes.
Where does it get the content from? How does it decide?
Okay. As per GPT goes, you actually went out to the internet, look at the prompt that I provided, and then create it for you. Now, it comes back and create this content for you, but if you are not happy with the titles, for example, you're actually able to edit it to your preferences. So it basically provides you a first step to create the contents for you. So imagine you're managing a content website for more than 3,000 pages. So this actually eliminates a lot of the process that you need to take. Right?
One follow-up question.
Yes.
From a copyright point of view.
Yep.
And like, I know with GitHub and Copilot at the moment, and I'm sure other similar tools, there's lawsuits going on about whether or not the model should be trained against like open source code, for example. In this case, like I'm assuming there's content on the internet that is quote unquote copyrighted or proprietary in some way.
Yes.
Is there a way to like differentiate that? Or?
No. So the technology that I'm demonstrating is that you can actually use any generative AI to bring the content back to your content management system. So in this case, I'm just using the open, basically ChatGPT. But you can use Bard, you can use anything, you can use your own LLM as well.
So you have to be careful, basically.
That's right. Yeah. So you still need a human factor to go and analyze what actually generated, what generated. All right. So this is just a demo that we have done for Siphoninity Cloud and with our native chatbot. So there's no reason why you can't use it for other languages as well. So as you know, we actually support more than 70 different languages. And as part of the course, if you were to use Siphoninity Cloud, we actually do include auto scaling, includes CDN, WAS, and SIEM as well. So, given that some of the earlier topics was about cost, so this is actually one of the ways that you can actually manage your cost as well if you are to create a content management for a big group of users or websites. All right. Any questions? Nope. All right. So the other part of this is that once you have created a website or content, essentially, the other part is you need to measure how your content works. So we actually have this thing called Siphoninity Insight, which is able to integrate with what you have created, and then as you let the user browse the content, you can actually use it to personalize, to do A/B testing, and also to understand whether the contents are relevant. Then you can get the GPT to regenerate a new set of content to maybe attract different groups of users. So all these are actually part of the offerings from Siphoninity as well. So all these are one cost. Yeah. All right. And then actually I don't have much more to add on. Do stay on to the end of the day because we actually are offering some swags from Progress as well. All right. Yeah. Good. Yep.
Thank you.
My name's Aaron Saikovsky. I'm a former Microsoft employee. I used to be a customer success or CSA engineer. I'm starting a new role soon, so watch this space. This is my details if you want to connect with me on LinkedIn. I've been in this IT industry for a long time, over 30 years. 9 of those have been in Azure. So I come from a developer background. So I've done a lot of dev work, DevOps work, programming, architecture, deployment, you name it. So I've done a lot in Azure. Am I an expert in everything in Azure? I am not. But I know what I know, and I've done it for a long time, but there's always something to know with Azure. So yeah, so as I said, I've done a lot of interesting deployments and work with Azure over the years, and feel free to connect with me on LinkedIn. So what we're going to look at is infrastructure as code, very quickly overview what it's all about. Talk about Bicep a little bit. Who has never heard of Bicep before? It's okay, put your hand up. There's no, okay. Who's never touched infrastructure as code before, but who's never touched it themselves? Who knows? Does everyone know what it is? Okay, who's got a rough idea? Who has no idea? Don't be afraid. This is not a, it's okay. No, it's all good. So this slide's for you. So very quickly, infrastructure as code is all about representing your infrastructure in a repeatable, secure way. So human readable, it's not machine readable, it's not binary, it's a human readable way of defining your infrastructure. So it's designed to be very modular. It's got to be declarative, and we talk about that a little bit. Ultimately, what the state or the end state should be. I want 5 virtual machines in a virtual network. This is how it should look. That's what this will define. And it's obviously automated. That's why you're doing infrastructure as code, right? So you're not doing things through ClickOps. Who's still doing ClickOps here? Put your hand up, be honest. I see it a lot. Oh, that's okay. Everyone does to start with. Okay. So what are the benefits of using infrastructure as code? So I don't really call people out here. It's all good. So what are the benefits of using infrastructure as code is obviously you get high quality deployments, high quality of changes. Also you've got standard and approved patterns. So things like well-architected framework and cloud adoption framework from the best practices from Microsoft. So when I used to work at Microsoft, and I still do this with customers, is making sure they do things in a repeatable, proper way, following a standard pattern with security, enterprise scale landing zones, all of that kind of stuff. It allows me to distribute changes if there's benefits to the infrastructure as code, reduce permissions, so I don't have to log in as an admin. I can run it as like a service account or a service principal, something like that, with a secured logon that can actually do the deployment. I don't have to log in and use my account to do it. Obviously the permissions, there's less complexity, standardized naming, very important. So machine names, virtual machines, network interface cards, all of those services have a standard construct for their naming of those resources. And testing, that's probably the biggest thing. So it's software. So, sorry about the microphone. It's software-based infrastructure deployment. So networking, storage, any of those resources you deploy in Azure are done through some sort of software mechanism. Okay, so Terraform, you can do it through Terraform, PowerShell, Bicep, Pulumi, whatever your poison of choice is, you can pick it, it'll go and do it for you. Which brings me to Bicep. So what is Bicep? So who's heard of Azure Resource Manager or resource templates? Who's got a bit of an idea of what they're about? All right, cool. So this is like the next evolution of resource manager templates or ARM templates. They've been around for a while. There's nothing wrong with them, but they're JSON. I'm not a fan of JSON, to be honest. Bernie will talk about this afterwards as well. He's not a fan of it either, I don't think. So the idea of Bicep, it's the next evolution of being able to deploy your infrastructure, and it's designed to be easy to learn, very quickly to deploy, and you don't have to have any programming experience. It's not a programming language. It's a declarative way of defining what I'm going to deploy into my Azure estate. So what happens is, and I'll show you, we'll go through this in a little bit in a demo. Hopefully I've got time for the demos for a short session. What happens is Bicep is a transpilation, will transpile into a JSON template. So Azure doesn't understand Bicep. Bicep is a human readable representation of the infrastructure we want to deploy. JSON, Azure understands what JSON is via the APIs, via the endpoints and whatnot. So it understands what JSON is. We can kind of work it out too. But from our perspective, using Bicep, it's much more friendly, human readable, tooling and all that in place is there for you. Make sense? Any questions? So Bicep, human readable, ARM templates, more machine readable, if you will. More Azure understands ARM templates per se. Now, this is one thing that's important to understand is how Azure Resource Manager works. Who's never come across this slide before, has no idea what this is all about? I like to ask a lot of questions, try to make it a bit interactive for you. So when you go and deploy something in Azure, a few things happen. You can interact with Azure through various means in the bottom left-hand corner. Can everyone see those okay? These are on the internet. You can get, I'll share these slides out afterwards if you want them as well. So when I go and deploy something through Azure Resource Manager, it goes and handles it. Think of it as like a traffic cop. It goes and works out what I need to go and deploy. So it goes and works out, I need to deploy a virtual machine, you know, virtual networks, interface cards, all of that. It works out which order it has to go and deploy it and go and deploys it and orchestrates that deployment for me. And I can do that through various means, via the Azure portal, through PowerShell, through the CLI, and through REST clients. A REST client is just an API call into that endpoint to go and provision that. At the end of the day, it's calling Azure Resource Manager to go and deploy those resources for me. And the most important thing here, I haven't got my laser pointer, is this guy, authentication. That's Azure Active Directory. So ultimately, I have to authenticate to Azure Active Directory to prove who I am, authenticate an authorized user to go and be able to do this, be it a human user or an automated user, like service principal kind of thing. So that's very important to understand. The second thing here is this concept of a control and data plane. So when I do a deployment, that's the control plane. That is basically the orchestrator that will go in and do that deployment for me to say, go and provision all that infrastructure, go and orchestrate that deployment. Now the data plane, go and configure all the settings on those different resources. So for example, Azure Key Vault, go and deploy an Azure Key Vault, go and set the access policies. The access policies are controlled through the data plane. It's all done via APIs. When you think about Azure, just think about it as a really big mesh of APIs. Really, that's all it is. And AWS is pretty much the same. So Azure Resource Manager sits atop all of that to enable me to go and deploy those resources. Now, each of those resources has what they call a contract to Azure Resource Manager to say, for me to be able to be deployed by you, I've got to have a contract back to Azure Resource Manager to allow me to be orchestrated by you. So at Microsoft, all the different product teams bring all their different services out. They have to talk basically ARM, Azure Resource Manager, okay? It's an important concept to understand how Azure works. Now at the top here, top left, you've got resource groups, resources. Who's not familiar with this concept? Put your hand up, it's okay if you're not. That's okay. So a resource group, think of it as like a container for my resources. And a resource group can be in a particular region, and my resources go inside a resource group. But the resources themselves can be in a different region to a resource group, if you so desire. So typically what the recommendation is have the resources default to the default location of the resource group when you're doing a deployment. Typically that's the accepted practice. The only reason you wouldn't have a resource in the same location as a resource group is if the service not available in that particular region. So AI, for example, may not be available in Australia East or something like that. It's important to understand this concept too, so just make sure you've got your head around it. So Azure Resource Manager handles all the deployments, orchestrates everything for me. I can call it through code, through PowerShell, through CLI, through Python, whatever I want to use. It all talks Azure Resource Manager. But I have to authenticate before I can do that. Otherwise, all bets are off. It'll give me an access denied or give me some error message, something like that. Cool? All right. Any questions on that so far? I know it's not the most exciting topic straight after lunch. I dread doing sessions after lunch, particularly everyone's just like, oh. Anyway. So we'll switch to some demos. So hopefully we'll get time to go through all of these. I'm going to show you how to migrate to and from Bicep ARM. I'll swap between them and I'll show you some scenarios where you would do this. How to use modules. Now this is probably the biggest takeaway you can use with, this has been around for a while with Terraform. You can do this inside Bicep as well. So local and remote modules, we'll talk about what they are. Don't panic just yet. and how to do some basic validation and testing. And there's a few different ways of doing this. So let's get into it. Any questions on that? Everyone good? Everyone's still awake?
Yes, yes.
Just wave your hands in the air. Everyone get awake. All right, beautiful. All right, so let's do this. Wait, why can't I see that? I might have to just represent my screen. I'll have to go to other slides, I think. Look at that rookie error. All right, so I'll just walk you through a scenario here. I've got a few resource groups. It's not important what they are, who created them, anything like that. So for example, here I've got a demo resource group. You can see in here, now this is actually a common scenario I come across quite a bit. Someone's gone and deployed a whole bunch of resources in here in this resource group. I've got a storage account, I've got virtual machine, but I don't know who did it. I don't know how they did it. Help me, Aaron, how do I automate this? So being the good DevOps engineers that we all are, everyone's a DevOps engineer, you just don't know it yet. What you have to be able to do is basically reverse engineer this into some sort of code. Any ideas how you would possibly do this? So say your boss comes to you Monday morning, we've got this, we've taken on a new client, they've got this virtual machine, help, how do we do it? Any thoughts on how you could possibly do this, how you would tackle this? Bingo, that's probably the first place I would start. So what we do here is we go to, where am I? Back to my resource group. Where am I here? Did I not share that properly? I probably have to zoom out a little bit, don't I? So what I do is I pick that resource group. Now what I can do here is export template. So what this will do is effectively export this into a JSON, two JSON templates, one parameter, one template, the template being what has been deployed. Now, just watch out for this one because it hard codes all the values. So if you go and do this and export it, you've got these hard coded values and it's quite a bit of work to go in and refactor it. This is a worst case scenario. And I've actually seen this with customers where someone's gone and deployed a whole bunch of stuff. They don't know what's in there. They want to make it into some sort of codified version of it. They don't have the code for it. So that's what this will generate for me. It's a little bit funky with the resolution, isn't it? So that's the template. You can see here, this is the template. This is an ARM template. So you can see here, it's not really human readable. I'm not a massive fan of JSON myself. I mean, when I first started using Azure, this is all you had. Otherwise, hacking the APIs, and they were fun days, let me tell you, especially when you miss a comma. And the tooling wasn't there and spaces. So they were having flashbacks. So anyway, you can see here the values, particularly here, if I zoom in a little bit, if I get my little drawing tool, I am on a Mac, so drawing is a little bit funky on this. You can see here things like Australia East. It's a bit hard to see, sorry, up the back there, but you can see Australia East, it's hard-coded. So what I could do is export this, take that out, and just export it and remap all those values. It's a fair bit of work to do that. So you could do that. That's one way. So whoever said that, perfect. That's probably where I would start. The other way you could do it too is you can go into Visual Studio Code as well. So it decides to zoom in a little bit. Oh, I need to get rid of that, don't I? So what I can do in VS Code, it's a little bit hard to see as well, is if I've got the tools, the bicep tools installed, I can go to Insert Resource. So what I can do here, this is a very, very clunky way of doing this. I recommend not probably doing this way, but I'll show you what I'm going to do. So if I go to my import bicep, I've just got a blank file. What I can do here now is go Control-Shift-P and go Insert Resource. If I go back to the Azure portal, now what I can do here is go to, say, my resource group. My mouse decides to play nice. I go to the properties of that. And I need that resource ID. I copy that. So from the resource ID, this is why I don't recommend doing this. This is a real sort of hacky way of doing it. So I go Control-Shift-P again, Insert Resource. Control V. What it will do, it can go in, but it's only done the resource group. So what it's gone and done is go and called out to the API, gone and captured the resource group via that resource ID, pulled that information in and turned it into a bicep template. But what about all the other resources? Well, I got bad news for you. You got to do them each and every individual one by their resource ID. So that's why I wouldn't do it this way. All right? So not cool. So what I'll show you as well is I've got this, I'll zoom in a little bit on this one too. Can everyone see that okay? It's not too blurry? It's okay? So I'm not going to go through the details of this, but this is for those who have not seen Bicep before or haven't seen this. This is the JSON definition of what we're going to deploy. Now it's going to deploy a whole bunch of stuff in here. It's going to deploy a virtual network. I think it's going to deploy network interface. It's going to do this thing with depends on. This is very important too, is this dependency hierarchy. So in the old days of ARM templates, this is the way what you had to do. You had to make sure your dependency hierarchy was in order. Otherwise, if you tried to deploy a virtual machine before you had a virtual network, before you had a virtual NIC, it'd blow up, it'd throw an error. So that's what this will do. It works out a dependency object graph of the order in which it's got to deploy those resources in Azure. So that's an ARM template. That's basically what that's going to do. And the parameters, it's just the parameters you pass into it. So you pass in, the username, password, or key, and the DNS prefix in this case, depending on what you're deploying. Rightio. So let's go to the real meat and potatoes, as they say. So this is for those that, for the gentleman at the front, you haven't seen a Bicep template. Now you have. So you can see this is much more user-friendly. And the good thing about all this is you've got all the tooling inside Visual Studio Code too. So you can start typing in res, and you've got these little shortcuts. If I want to spin up an AKS cluster, click on that, boom, it inserts all the code for me. So it's got all these nice little snippets in there. And I can pass all those parameters in dynamically and refactor that as I need to. So it's a really nice way of being able to, the tooling in Visual Studio Code is really nice. And you can actually do this in Visual Studio 2022 with one of the latest updates, I believe, as well. Personally, I don't really see the point of doing that. It's not really a dev thing, but you can if you wanted to do that. Questions on that at all? So that is so you look at this. Now I'll show you something else that's really nice. You get like a little visualizer as well. I don't know if you've seen this before, but this allows me to visualize these Bicep templates, so for documentation. So I'll zoom in a little bit. I can sort of move these around and show my boss and say, look how awesome I am. But that allows me to document what I'm going to go and deploy. So you can put this, you can export this and put it into your documentation. As I make changes to the Bicep file, it'll change that as well. It's just a nice way of being able to document what's been deployed. So as you can expect, I can go and deploy that. I'm not going to deploy it now because we're a bit short on time, but you get the idea. So this is a much more user-friendly way, human-readable way. Yeah.
Sorry, just a quick question. Is Bicep syntax standard or is it Microsoft specific?
Yeah, question is Bicep a Microsoft standard syntax? And yeah, so you think of JSON as just JSON, whereas Bicep is what they call a domain-specific language. It sits on top of an ARM template. So it's a Microsoft sort of language, like HashiCorp configuration language, similar sort of idea to that. One of the big things about Bicep that it has an advantage over Terraform, and I like Terraform, there's no state file. Any claps? I'm not a Terraform hater. I like Terraform, but there's no state. Now, the tooling in here is very, very nice. Now, one thing I do want to point out, remember, if I can zoom in a little bit, get my little thingo again. Get my green square. Remember before how I was talking about in Azure Resource Manager, the concept of a resource provider? You know, I've got those resources that have to subscribe to the Azure Resource Manager. This green square is the resource provider. So each of those resources in Azure has to be able to talk via an API to the Azure Resource Manager. So to define the version of the API, Microsoft's version of their API is via a date, 2021-05-01. I recommend not using the preview versions of the APIs in production either, because there's often late-breaking changes. So make sure you use the generally available released versions. You're probably thinking, why do we want different versions of the APIs? Well, as the services evolve and new features and capabilities are added to it, they update the APIs to match that. So I can go in and add extra values to match the version of the product I want to use. And they're backwards compatible as well. But you've got to test them. Now, the big problem you're going to have is if you don't look after these, it's like a garden. They'll grow weeds very quickly, and you've got to go back in and refactor some of those over time. I've seen one customer recently, they haven't looked at these in 6 years. So the templates will still deploy, but there's new features and new capabilities that come into the services that are not reflected in the version of the API they were using. So just watch out for that one. Now, as you can see, it's quite a large amount of code here. It's about 187 lines of code. If I go back to the ARM template, it's 269. I've worked on templates that are thousands of lines code in ARM templates, and you do it in Bicep, and it's a fraction of that. There's less code to write and manage. So remember, Bicep is the human readable version of what we're going to deploy here. And obviously, ARM templates are the Azure. Think of it as a machine version of what we're going to deploy. Okay? Questions? Thoughts? No one cares? Okay. Now you can see here, there's quite a lot of resources in here. So you can see there's a resource, basically think of it as a block. Now this is all in one big script. Can anyone see a problem with that? Which leads me into my second part of this session, modules. So what I can do is if I've got a module that goes and deploys like a storage account, all I need to do is create a separate Bicep file to put for instance, a storage account in here, put it in a separate file and reference it from another Bicep file. It allows me to chain these together and create modules. And I'll talk about why we want to do this in a sec. I was going to keep an eye on the time too. So this allows me to do modules. Now what I can do with the module, if I go down to my local, you can see here, I want to deploy the storage account. I'll just get my little green little square. You can see here, all I'm doing is referencing the module locally, passing in the parameters to it. So all I'm doing is basically providing configuration to my infrastructure to go and deploy the storage account. And I can programmatically change those values to go and deploy that infrastructure using a module. This is local modules. This module is working on my local machine. Now, there's a really cool feature called remote modules. Anyone heard of that? Anyone not clear about modules? So think about this. We've got a resource. We're putting it into a separate file. We're referencing it from another file just to make the concept of encapsulation for those developers in the room. So that's a local module. Now what I can do is if I go back to the trusty Azure portal, I've got an Azure container registry. What I can do here is I can create a repository and I can put that same module into the repository as a remote module. So I can share this with my co-workers and I can version these. So I could share this module with all of you. You could use that module and create your storage accounts to your heart's content. So that's what the concept of a remote module will do. This is a private registry too, so anyone on the internet can't get to it. So we can't get any dodgy actors out there, creating storage accounts using my module, unless I give them access to. Yeah.
I'm presuming you can also import or have modules just with variables as well.
Yes. So what I tend to do is you can use the parameters file to control. So the question was you can use a module for your parameters. So typically what I do is I actually create a file, a Bicep file, just for my variables because you get all the nice tooling and everything inside VS Code rather than using through the JSON file for the parameters because you don't get much tooling. JSON's JSON. You can't put comments in it and stuff. And the other thing I can do as well is obviously I didn't touch on this. We'll talk about this in a second. Is I've got the module here, but you see here the syntax is a little bit different. If we go Control A, you can see here it's a little bit different. It's still referring to the same module, but it's referencing it via the Azure container registry via an alias. Don't worry about this too much. It's what it's doing. I'll give you a link on how this works as well. I've got a link of resources I'll share with you folks. It's referencing that module via remote reference with a Git tag for a version, passing in the parameters to it. So it's pulling that module in from a remote repository to go and be able to deploy that. There's a bit of plumbing you need to do for this. You've got to create a container registry, publish the module, but that's really it. And the other thing you need to do is you need to fiddle around with this file, the bicep config JSON, to basically set up what they call an alias to point to my correct Azure container registry to get that module reference. Okay. Now the other thing I've got too, I didn't show you this, I think I skipped over this, is I've got this ARM template, and you're probably thinking, oh, well, that's really good, but what do I do with this? Well, I can convert it to a bicep file. I can also, it goes two ways. I can convert an ARM template to a bicep file, but I can convert a bicep file to an ARM template, which is what Azure does. You present a bicep file to Azure. It'll do this concept of transpilation. It'll convert it to an ARM template so it knows to consume it and then create the resources for you. So to do that, I go to change directory, demo 1. There we go. So what I can do is bicep, what is it? Oh, it's AZ bicep. So it's AZ bicep, decompile. So what this is going to do is convert that Azure deploy JSON file into a bicep file for me. So the ARM template into a bicep file. And it does give you warnings as well. So make sure you address those warnings and make sure you go in and factor in. If it gets red, you've got problems. If it's yellow, you've got a few problems. Not too bad, right? So if I go to Azure deploy bicep now, all it's done is created the bicep version of that ARM template. I've converted, so walking through that workflow, I've exported that ARM template from the Azure portal, put it onto my local machine. I can refactor it, fiddle around with it in JSON. Now I can convert it into a bicep file using that AZ bicep decompile -f, give it the file name. Now I can go the other way. I can convert this bicep file into an ARM template. So I go bicep build. This is effectively what will happen when Azure gets this. So I'm sort of simulating what happens to Azure. So I do bicep build -f, and I give it Azure deploy. Deploy. If I can type properly. Oh, it's. Computer says no. Anyway, take my word for it. You can do it the other way. So if we go, yeah, I did, because I used to have it set up with an alias. So the command is AZ bicep, and you can check which version you've got too. So if you go to AZ bicep, you go version, I think it is. It tells you what version you got. Yeah, so CLI version. So don't worry about that too much. So yeah, you can go the other way as well. So AZ bicep. I've got to go change the directory. I won't worry about it now because we're a bit short on time. The other thing I wanted to show you too is validation and testing very, very quickly. So what you can do here is I've got a script that I use. I'm a big fan of the Azure CLI. A lot of people ask me, why do I use the Azure CLI over PowerShell? Personal preference, there's no reason. I just prefer it. You can see I'm running a Mac. I'm an open source kind of guy. What I really like about this approach, though, is I can almost copy and paste this code exactly how it is and put it into a GitHub action or DevOps pipeline, which I've done in the past. So I can sort of test it locally. I can do validation. I can validate my resource group. I can validate my deployment, and it gives me some nice ways of testing sort of stuff locally to make sure that my my deployments and that are working. And I can share this code with you guys. There's nothing super secret. So I do validate. I validate it against the resource group. I do a deployment. Someone was asking me about the what if deployment parameter. What this is going to do, it's not actually going to do the deployment. It's like a Terraform plan. It's basically what it's going to do. It's going to say, go and do a deployment, but don't do the deployment. Tell me what you're going to deploy. Give me a report and tell me what has been changed. And I can rerun this a few times to see what has actually been, what's going to be changed between the deployments. Well, yeah, back to the slides. Oh, sorry about that. It's this microphone. It's in a weird position. I'll share these slides with you too. This is just a list of points to think about in the short amount of time we have. Keep your bicep versions updated. Use modules where you can. Encapsulation is very important. Reusability, predictability. Test your code. Test locally. Highly recommend looking at pre-commit hooks on your code if you can to do testing locally. Use PS rule. Bernie's the man. He's in the corner over there, hiding in the corner. If you want to ask him about PS rule, he's the man who developed this, so he's the guy to ask about this. When you're refactoring your code, don't use any hard-coded parameters, set defaults. Try to use parameterization as much as you can, and please don't store passwords. The other thing too is think about how you're structuring your bicep code. So the practice I typically follow is main.bicep, so it knows what the main is and everything else can sort of hang around it. Similar if you work on big projects, main.bicep is the stack, all the modules sort of hang around it. Use what if. You can use tools such as there's one called bench press, allows you to do unit testing. Follow the Microsoft best practices. VS Code is your best friend tool too as well. So use that, use the tooling, use the linting tools, and automate everything as much as you can. So you can grab a copy of that slide if you want, get a photo. This is the one you should get a photo of. So bicep releases, they get released every month. One of the things I haven't talked about is the common Azure resource modules. That's a talk for another time. I would highly recommend using those. Rather than building your own modules from scratch, use those. Trust me, you'll thank me later. GitHub Actions, how to set those up, how to set up bicep pre-commit hooks, PS rule, the bench press unit testing framework, best practices for bicep templates. And every month there is a community call with the Microsoft product team. You're welcome to join. It's at ridiculous times in the morning, but you can sign up for it and you can hear straight from the horse's mouth the folks that are developing this stuff. So I highly recommend you sign up for that. Cool. So thanks for that. Any questions? I think I'm right on time. I'm a little bit over. Everyone's spaced out from lunch. Why'd you put me on straight after lunch? Yeah.
After importing as well, we can like identity code, right?
I'm sorry?
So after importing it to the bicep, you can again refactor the code.
You can, yeah. So what you